Welcome to the Minds of Machines channel. Today, we are going to learn about hidden layer neural networks. In this tutorial, we'll dive into how a small artificial brain, or neural network, processes information through its layers. We'll set up one layer to handle some example data X, and then use a method called ReLU to ensure there are no negative values in our output. Join us as we explore how the network learns by adjusting the importance weights of data features, gradually improving its predictions. Let's get started.
Let's go through each line of the provided Python code that uses NumPy to create a simple neural network with a dense uh, layer followed by a ReLU activation. First, we will import the NumPy as NP, and it's a library package for scientific computing in Python, and it provides support for large multi-dimensional arrays and matrices along with a large collection of high level mathematical functions to operate on these arrays. Next, we will be using the NP random seed, which sets the seed for the NumPy random number generator, and this is done to ensure reproducibility of the result, and it ensures that the random number generated are the same every time the code is run. Now we are defining the input data X, and this is basically a list of lists where each sublist represents a set of features for a data sample, and this particular input consists of 3 samples each with 4 features. Next, we will define the class layer dense, and it is used to create a dense fully connected layer in neural network. Then we will define an init function, and which has certain number of inputs and neurons. Then we initialize the weights and to a small random value from a standard normal distribution scaled by 0.10 to keep them small. Then we initialize the bases to 0, and bases are initially set to 0 vector with a length equal to the number of neurons. After that, we will define the forward method. This method computes the output of the layer when given a set of inputs. Next, we will define the to perform the forward pass computations, and it calculates the dot product of the layer when given a set of input. After that, we will define a class activation ReLU for ReLU activation functions. The ReLU activation function is one of the most commonly used activation function in artificial intelligence neural network, particularly in deep learning, and it is defined as you can see. And its characteristic is its non-linearity. Despite being a simple piecewise linear function, ReLU introduces non-linearity in the model, which helps the network to learn complex patterns. It also produces pair activations, and the ReLU function is computationally efficient because it involves simple operation, making it faster to compute than other activation functions like sigmoid or hyperbolic tangent. Then we will define the forward function, which defines the forward method for the ReLU, and this method basically computes the ReLU of the given input. Then we copy the code, that is by setting the self output is equals to np maximum between 0 and the input, which is computing the ReLU activation. The ReLU activation outputs the input itself if it is greater than 0, otherwise it outputs 0, hence removing all the negative values. Then we define the layer 1, in which we create a instance of layer dense, and this layer has 4 inputs and 5 neurons. Then we define the activation ReLU by creating an instance of activation ReLU. Then we execute the forward pass of layer 1 using the input data X. After that, we print the output of the layer 1 after the forward pass. Then we execute the forward pass of activation 1 using the output from the layer 1. Then we print the output of the activation 1, which is the final output after applying the ReLU activation function. So this is how you set up the code for set up the code for basic neural network architecture, which processes the data through one layer, applies a non-linear activation function, and outputs the result, illustrating foundation of neural network. So as you can see in the first we have showed you the layer 1 output, but when you apply the ReLU, it removes all the negative values in that output and makes it to 0 if it is negative, and whichever is positive it shows as it is. So this is how we use the ReLU function in our neural network. So thank you for watching this video. We hope you found this informative and engaging. We will be back with our next tutorial soon. Until then, stay tuned and keep exploring the exciting world of technology. Don't forget to like, share and subscribe for more updates. See you next time.